Welcome students. Today is the lesson number 18. In this lesson I will discuss about the different parts of the total station. The lesson will be discussed under following heads. First I will introduce the lesson, then I will talk about the different parts and their functions, followed by summary, review and further reading. Now already in the last class we have seen that a total station is an integrated unit consisting of one electronic theodolite consisting of this vertical circle as well as this telescope. There is a EDM and also there is a microprocessor that is kept inside it. Now to carry out defined functions we using this electronic theodolite to measure the horizontal and vertical angle, to measure distance using the EDM, and to do it automatically using the microprocessor we need to have many other parts. Now I will discuss those parts. Primarily the instrument total station consisting of two parts. One is the upper part called elidate, and this is the upper part, this is the elidate, and this is the lower part called Trebek. Now using this fixing screw we can open the instrument out of this Trebek, or we can also fix this elidate to the lower part. Now as I told you that this lower part, let me explain about the different parts from the bottom. This is the tripod stand, and this tripod stand has to be placed over the station point in a leveled way. Then on this tripod stand generally we keep this instrument together, or sometimes we may use the Trebek stand only. We can keep it apart from this part and we will make this Trebek here fixed using this screw, and this Trebek is, this is the level head or base plate, and this is the Trebek on which this instrument or elidate will be fixed. And in this Trebek there are 340 screws which we use to level the instrument, and also this is used to perfectly level, and then once it is used then we make use of, we fix it, and we have to make use of this fixing screw to fix the upper part with the lower part. Main important part of this is the telescope, because this is the part with which we do direct our instrument to the point or the object to which we have to bisect it. This telescope is having the objective lens, it will be kept towards the object, and there is a eyepiece lens, this one, through which an observer will see. Near this eyepiece lens there is a reticle here, and at this reticle there will be crosshairs. Reticles are like this, within this you will be getting the crosshairs like this. So we have to take the measurement along this line. Now this eyepiece, there is a screw which we can rotate so that we can see clearly this reticle and the crosshairs from here, and another circular focusing screw is there, this one is the circular foot screws which is used to focus the object, and the image of the object is tried to be maintained at the plane of the reticle, so that we can get the object reflected on this point, on this crosshairs. Now the most important point of this telescope is the line of sight, which is the line joining the optical center of the objective lens and the eyepiece lens, and it is beyond. And this line of sight, when the vertical circle reading is 0, then or 90 degree, depending upon whether it is measuring the azimuth angle or the altitude angle, this should be perpendicular to the horizontal axis, so or turn on axis. In the last class I have told you that the instrument is having a horizontal axis passing through this point, about which the telescope can rotate. So in a perfectly level instrument, when the vertical circle zenith angle is 0 degree, altitude angle is 0 degree, then the line of sight should be perpendicular to the horizontal axis. Now one more thing, whenever we will take observation looking through this telescope, the image of the object will be forming at the reticle plane. Now there may be some parallax between the image formed and the reticle, that we should be able to identify by moving our eyes up and below. If the object and the reticle moves together, then there is no parallax, otherwise there may be relative motion between the object, between the reticle and the image. So if there is a relative motion between the reticle and the image, then there is a parallax, and that has to be removed before taking the reading. Now with this telescope, actually this telescope rotate about the horizontal axis like this, and also this telescope may rotate about the vertical axis. Now in case of a manual instrument like this rotation about the vertical axis can be is regulated by using this screw. This is called vertical main screw. Now if I fix it, there will not be any movement, the telescope is not moving. So this is, and if I open it, the telescope can be rotated about the horizontal axis in a vertical plane. So this is called the vertical plate clamping screw. Now when we will bisect any object, and we have fixed the main screw, main vertical screw, but if we need to move it slightly, we can move this one. This is called tangent to vertical screw. So there are two screws, one is the main vertical screw and another is the tangent to the vertical screw. Now similar to this, there are two other screws. This one, if we fix this one, then the telescope will not be able to move about the vertical axis. That means this is the horizontal plate main screw. Now after bisecting the object, if we want to have very little fine adjustment along the horizontal circle, then we will be using this screw, and this is called horizontal plate fine screw or tangent, horizontal plate tangent screw. So these are the two screws which are important, this one and this one. This one is called vertical plate main screw, this is the horizontal plate main screw, this is the vertical plate tangent screw, horizontal plate tangent screw. Now these are the main salient parts where we are associated with the telescope, and operating these vertical plate main screw, vertical plate screws and horizontal plate screws, we can take the telescope and we can bisect any object using this telescope. Now in this telescope, also there is one part which is inside this, probably it is difficult to see. If we look at it very near, there will be a hole like this. Actually this is a point through which laser beam comes out. Now this is a mechanical instrument, so we have to focus the object using the objective lens focusing screw, but in some instrument there is another arrangement above this telescope, which if we press, then the focusing of the object is done automatically, that is called autofocus. So in some instrument that arrangement is also available. Now as I told you, this telescope will be leading to the horizontal circle reading or vertical circle reading. This is the horizontal circle reading, this is the vertical circle reading, and the vertical circles are available here. So there are two parallel plates which are kept vertically here, and when this telescope is, when the instrument is properly leveled and telescope is looking towards zenith, if we point this telescope towards zenith, then the vertical angle reading will be 0, that means zenith angle 0. Now and for any horizontal angle measurement, this is the horizontal plates. There are two horizontal plates are there. We will learn more detail about these plates, and using those two plates, actually one is rotor, another is stator. One is rotates, one keeps in static condition. The mutual movement of these provides us the horizontal reading. So one more thing, when the instrument is properly leveled, then the horizontal circle will be in a horizontal plane, and there is a automatic arrangement in which, through which the vertical circle will be perfectly in a vertical plane. So the verticality of the vertical plane will be done automatically, or will be achieved automatically by the instrument once we make the horizontal circle in a horizontal plane by using these foot screws and other arrangement. Now in a total station, all the works like taking measurement, once we focus the object using manually using these vertical circle and horizontal circle screws and pointing the telescope towards the object, by using this keyboard or keypad, we can make the measurement, and all those measurements will be done through software installed in it and through command through these keypads, and these works are done inside through a microprocessor. So microprocessor basically controls, measures, computes, reduces observation data by providing commands through keyboard. So there are different types of commands in the keyboard. By making use of suitable command, we make use of the microprocessor inside it to control the instrument, to measure the data, to compute the data, measure generally total station, as I already told. Total station measures slope, distance, and it measures horizontal angle, and it measures vertical angle. This is what is the measured. From this measurement it computes the horizontal distance, in the last class we have told it, then vertical distance, these are the components it can compute, and from these are the computation, this is the observation or measurement, this is the computation, and using this it reduce the data to location, that means coordinate and elevation. So these are the reduction, so this is the reduction. So all this works, observation or measurement, and then computation. So now these measurements are done by using some particular keys in the keyboard. Always after the measurement we can make use of some keyboard to compute it, and after computation we can use some keyboard to find out, to reduce the data towards this, and again we can store it, we can display it by using some keys in the keyboard, and all these functions, measurement, computation, then reduction, then display, then store, all these works are done through software and making use of the microprocessor. Further, some more functions like we can make use of the microprocessor to make the circles 0, because to start with we may start angles from 0 0. So we can do that thing using the microprocessor. We can observe angle by method of iteration in any direction, that means suppose we want to measure the horizontal angle between a number of points C, D, E. So we want to find out what are the angles. So our instrument is kept at this point, we want to know what is the angle, this one, this, this. So this is called, and automatically, because you know, if I go back to this point, that will make the 0, 360 degree. So angle A, angle B, angle C, angle D if we say, and this is the angle of E, summation of this angle will be 360 degree. So and this is the, by making this measurement subsequently, this is called method of iteration. So microprocessor we can make use of microprocessor to measure these angles. By method of repetition, that means suppose I want to measure this angle very accurately, so I will take measurement of this angle, then again this angle, then again this angle, then again this angle, like the same angle number of times, that is called method of repetition. So this is also can be done by using microprocessor, and then we can take the average using the microprocessor, then reducing slope distance to vertical and horizontal distance. Already I told you that this is the observed measurement parameters which can be converted to vertical distance and horizontal distance, and that is done by making use of the microprocessor. Then like coordinates, location, and all these things we can do by making use of the microprocessor in this instrument. Further, as I already told, that if we have level this instrument properly, then our horizontal circle will be in a horizontal plane, and once the horizontal plates or horizontal circles are horizontal, then the vertical circle will be perfectly vertical, and that is done automatically by the instrument by using an element called automatic compensator. So automatic compensator is the part which makes the vertical circle exactly vertical when the horizontal plates or circles are horizontal. And there is another arrangement, this one, that is called optical plummet or plummet. Depending upon whether it works optically, then it will be called as optical plummet. In some instrument this part is worked by using some laser ray, they are known as laser plummet. So what it is done, there is a eyepiece here, so by adjusting the eyepiece we can, and this is an eyepiece and also there is a reticle here. So by using this eyepiece and this adjusting screw we can see the reticle clearly. Then there is another screw here which we can make use to see whether our instrument is exactly on the top of the instrument station or not. So that is called centering operation. Centering means to make or to make the instrument vertical axis to pass through the station location. So that is done, that is can be achieved by making use of this optical plummet. So once we level the instrument, then using the optical plummet we do make this instrument just vertical axis just passing through the station point. So and that is achieved through this plummet. Actually through this plummet it provides us a line of sight that is directed downward collinear with the vertical axis after leveling. Now in case of laser plummet, actually whenever there will be some arrangement to press or through which we can send a laser beam, and then laser beam will strike exactly on the top of the instrument station. So if it is done, then we can say that the instrument is properly centered, otherwise we have to do centering. Another arrangement in some instrument above this EDM in towards your objective lens, like you can show, I can show it here. This is an arrangement. In some instrument only one, in some instrument in the both up and down of this. There is an arrangement called optical guidance system. Now these are light emitting diode, and if we which enables the detail pole to be set directly on the line of sight. So optical that means light emitting diode which will emit some light, and that light will be directed towards the object to which we are bisecting, and if it is bisected properly then it will provide us an indication. Otherwise if there is some misadjustment between the direction of the object and the direction of the bisection, then there will be some other kind of lights which guides us to rotate it and bisect it, the telescope exactly on the object. Now here is an example that if we may get increased flashing light, then move towards to a total station. That means if we see that it is that optical guidance is giving very strong light flashing, then we have that object should be taken for near the instrument, and if the flashing speed is decreased, then we have to take away the target. So like that there are some indications in this way in which provides us a guidance to keep the target as per our requirement. Now in this instrument there is also a communication port like this. This is a port in which we can we can fix USB, and also there is another port here through which we can communicate this instrument with some external device like computer, and through this directly we can make use some computer to upload or download the data, or we can transfer the data by using some pen drive here inside. So these are the communication ports. Now I already told this is the Trebek. This Trebek is primarily used for leveling as well as centering purpose also it is required, and also fixing the instrument with the tripod stand, and also sometimes we use this Trebek to replace this instrument, this part of the instrument by another instrument. So sometimes we do in the field to avoid the centering and leveling work to be repeated. So with this, and you can see some more devices, like this is the handle as it is shown here, handle. Then there is an arrangement called, it is not there in this instrument, here in this part we can fix Bluetooth antenna. Then already I have shown you USB port inside this, and then one more thing important is this one. This is the point which indicates the height of the instrument. So we have to measure this point from ground to this, we have to measure to find out what is the height of the instrument, and that has to be fed to the instrument. And then there is a circular bubble here. This bubble is something like this, and a bubble like this. So we have to bring this bubble inside this to indicate that the instrument is properly leveled. So this is the leveled condition. So this is done by using the 40 screws called site collimator or in collimator, and this is used to approximately bisect the object. When we will bisect an object, we will look through this collimator. There is a inside this collimator there is a triangle like this. So and whenever we will bisect the object, it should be like this. So optical, and then and already I have told you this is the fixing screw between your Trebek and the main stations. So with this I would like to conclude today's salient parts of the instrument, and so we can say that the total station can be divided into two parts. One is that upper part which is called elidate, and the lower part Trebek, and the elidate part can be fixed to the Trebek part by using a fixing screw. In the elidate there are three main parts, like your electronic theodolite, then EDM and the microprocessor, and to operate these parts we have many other smaller parts with like telescope and all this thing, and the lower part Trebek also having some like circular bubble, put screws, Trebek etc. And the whole of this instrument is an integrated unit, work as an integrated unit, and they function automatically by making use of the microprocessor. So with this I like to conclude today's class, and next class I will be talking on different accessories. Apart from the basic parts and the basic elements, there are some more accessories are associated or connected to this or maintained inside this. So that we have to discuss, and some of them are also external in nature. So, in the next class I will talk on accessories of total station. Thank you.